Hello, yeah, welcome back. So in this video, I'll show you how to run a regression analysis using the analysis tool pack add-in package on Excel. But before we do that, I have my data here already, and let me quickly just um, discuss briefly some things you need to know about regression analysis. All right, so now regression analysis is a set of statistical methods that you can use for the estimation of relationship between a dependent variable and one or more independent variables. So you would have a dependent variable, that is a variable that needs to be explained, or a response variable. And then we have um, independent variables. It can be one and it can be more than one. Um, Independent variables are the explanatory variables, that is variable that you would need to explain another variable. So basically that is what regression analysis does. And also it can be utilized to assess also the strength of relationship between variables, and also for modeling the future relationship between them. And there are basically two types of regression analysis. We have the simple linear regression, and in the simple linear regression, is always a relationship between a dependent variable and an independent variable. That is, you have one dependent variable and you have one independent variable. Now, if you look at this equation, y equals to a plus bx. Now, this is what we call the regression equation. This is the regression equation, where y is the dependent variable and x is the independent variable. Now, a is the regression coefficient that we are trying to estimate. So a and b, they are the regression coefficients that we are estimating. So in simple linear regression, we only have a dependent variable and also one independent variable. Now, then also we have the linear regression. Multiple linear regression. Multiple linear regression, in this case, it shows a relationship between a dependent variable and one or more independent variables. So in this case, we have more than one independent variables. Um, so this is the equation, just the same equation here, but we have multiple x's here now because the independent variables are more than one. So we have x1, x2, x3 as many independent variables that you have in the model. So where y is the independent variable and x1 up to the xn are the independent variables. Now let's go back to our Excel interface and see how we can use Excel to run a, a regression analysis. Now we are back on our Excel interface. Now you would see our data set here. We have the profits, we have the price, and we have the units sold. Now we want to make profit our dependent variable. That is, the price and the unit sold are the independent variable. So I'll be showing you two things here. I'll be showing you how you can run the simple linear regression, which involves just single independent variable, and also the multiple linear regression, which involves more than one independent variable. So now to start with, come to data analysis here, and then we look for regression. Here it is, and then we click on it and click OK. Now, so we have this dialog box coming up, and then we have the input, and then we have input y range and input x range. So y range is the dependent variable. So the range of cell where you have your dependent variable is the y range, while x range is the independent variable, or are the independent variable, depending on what you are doing. So for this case, let's start with simple linear regression. So that means we'll be using profit as y, which is the dependent variable, and price as x, which is the independent variable. So I would select this and then highlight the range of y, which is a1 to a8. Then also input range s, I will highlight this and also select everything from b1 to b8. Once that is done, the next thing is, do we have labels in our data set? Yes, we do, because the label we selected, profit and price were the label. And then it's constant 0, you just leave it like that. You are not using 0 as constant. Then the confidence level. Now, if you want to change, by default, the confidence level is 95%, which indicates that you are leaving just 5% level of error or significant level. So that means you are 95% confidence that your research or whatever you are doing is absolutely right. So now, if you want to change the confidence level from 95%, you could check this box and then change it to your desired confidence level. But for me, I prefer to leave it at 95%. Then the output options. Output range is where you want, if you want your result to display on this current worksheet, that is the existing worksheet, and the new worksheet applies, you want your regression to open a new worksheet entirely, and then new workbook is it opens a new workbook entirely. Then we have the residual statistics for the model. So you can pick any of these to see um, the residual statistics. So let me select this residual plots, and let's select line plots, and also I think it's okay. So now once that is done, I would like to change the output options to this range. So once that is done, I click OK. Wow, so the results of our regression analysis is out, and this is looking nice. Now, this a whole lot of statistical concepts. So we have the summary output, and then we have the regression statistics. We have the multiple R. Now, the multiple R gives us the relationship, the strength of relationship between the dependent and the independent variable. It works like the correlation coefficient. So this shows the strength of relationship between the dependent and the independent variable. So that is what multiple regression does. Then we have the R square. The R square is we also call it coefficient of determination, and basically it gives us the proportion of the variation in the dependent variable that can be explained by the independent variable. So the proportion of the variation in the dependent variable, that is the variation in profit, how much of this variation in profit can be explained by the independent variable, which is price. So now here we have 0.924, that is a 92%, which is a very good one. So this shows us that the variation in the profit is explained, by price with the magnitude of 92%. So that means other variables also contribute to the variation in profit, but price has a higher percentage. All right, so that is what the R square does. It's coefficient of determination, and it measures the variation in the dependent variable that can be explained by the independent variable. So it's coefficient of determination. Now, the adjusted R square here works the same way the R works. Now, the R square, the adjusted R square is the same thing with the R square, just that as its name sound, it has been adjusted. So, because statistician believes that the R square inflates its results, it exaggerates its results, believe that it says more than it should say. So the adjusted R square is um, a better a better replacement. So the adjusted R square is a better replacement to the R square. Then we have the standard error, which shows us the level of precision. The lower the standard error, the more precise the model is. Then we have the ANOVA. Now, what the ANOVA does is that it measures the um, it measures the significance of the entire model. Now, let me go back to how what I showed you earlier on here. Now, we have A equals to, Y equals to A plus BX, which shows um, this gives us the model, right? Now, what the value of ANOVA does here is that it tells us if that model, this entire model here, is statistically significant. So most times we compare this value, this significant value here, with 0.05. Don't forget, when you were setting your confidence level, we selected 95%, and 95% is telling us that we are leaving a 5% level of error, and that 5% error is actually 0.05. So we compare this value with 0.05. If this value is less than 0.05, then that the model is significant. The model is significant. But if this value is greater than 0.05, it shows that the model is not significant. Now let's write out the model. Now if you come to this table, you see intercept, you see price. Now here you see coefficients. This is where the model is. These are the coefficients. Let me adjust this a little bit. All right. Now, so these are the coefficients for the model. So let me just write it out now. Don't forget the equation we wrote the other time is y equals a plus bx. Now, here our y is profit. So we have profit equals. Now, what is our A? This is our A. The value here, the intercept value of the coefficient is our A. That is the intercept, the alpha. Some textbook use alpha. So let's say intercept, that will be 17.64. All right. Plus, now what is our B? Our B is this value here. The coefficient of B is this value here. So say 0.48. Let's say 480. Let's just leave it at 48. Now X is what? Is price. So type price. So this is our equation now that we got from the results here. So this equation is the same thing as this. Our Y is profit, our S is price. So what does this equation suggest to us? Now let's assume price is equals to 0. If price is 0, what will be our profit? That means our profit will be what? 17.64. So that means in the absence of price, the profit is 17.64 according to this model. Now, you notice that the coefficient of price is positive, which shows that an increase in price will lead to an increase in profit. That is, once price increases in magnitude, the profit will also increase. So that is what this equation is telling us. And then we have the standard error for each of the coefficients, showing us how precise or the level of precision that um, coefficient has. Next one, we have the t-stat. We have the p-value. Now, the t-stat measures the significance of each of these coefficients. That is, this t-stat measures how significant this coefficient is, this intercept. While this also measures how significant this coefficient is, that is price. So how do we determine that using t-stat? What we do is uh, we compare this value with a table value, but since we don't have a table value, we use the alternative approach, which is using the p-value. Now, just like the same way we did here, this value, this significance f, is the same thing as p-value. You can also write it as p-value. So this p-value, we now compare it with 0.05, the level of significance. And if this value is less than 0.05, if this value is less than 0.05, then we say the this parameter here, that is this coefficient, which is alpha A, which is 70.64, is significant. That is if this value is less than 0.05, that is our level of significance. Now, this value here, 0.000547, if it's less than 0.05, then we say that this coefficient um, is significant. So this value 0.000547, we will see that it's less than 0.05. This implies that the coefficient here, that is price, which is B, is significant in this model. Now, these are the confidence level for each of these coefficients. You will notice that this lower 95% is the lower um, limit, while upper 95% is the upper limit. So this coefficient would be between this limit and this limit. So the next thing is, let's see the residual output. All right, so the residual is just subtracting, when you substitute the value of price here and you get a figure, subtracting it from the original value of profit, then you have this the residual. So these are the predicted value based on the price that you have, and these are the residual. So now, residual also would mean the error, okay, the error in it. Now let's look at this graph. So we have the price residual plot, okay, showing us the residual curve. I'll be from negative, yeah, negative 2 to 4. So now that is the plot here. So it is this value of residual that was plotted. This value of residual was plotted here. Now also we have the price line fit plot, which gives us a profit, and also the predicted profit. So the profit now, so it shows us how close is the profit and the predicted profit. Look at the graph. Let me expand it a little bit. All right, so some of the variables are very close. So this shows to us that there is a significant level of relationship between price and profit. All right, and that this model is useful, is good. You can use it to predict, and you can use it to make decisions and conclusions. So we have come to the end of this video on regression analysis in Excel. So in the class forum, I'll be dropping more explanations on this result, on this output, in a PDF format, so you can go through it and get acquainted and familiar with it. So see you in the next video. Thank you.